An ancient oscilloscope with not one, but two traces. What is going on here? It's a beautiful thing. Here we have a TL072 op-amp. I can't remember who recommended it to me originally. It's from one of the channels. It could be Great Scott. It might be IMSAI guy or IMSAI guy. But you certainly have seen it around a few times if you are a devotee of electronics channels. It's the classic audio op-amp. So it's the one that's recommended because of low noise ratio, and it's supposed to. I have seen it actually at the heart of, I think it's like a 300 watt sound system. You can check that out online if you wish. But here it's not doing any audio duties whatsoever. It's just a classic op-amp relaxation circuit. So yeah, basically a blinky. And to do that, we've got 3 resistors and a capacitor. And this fourth resistor or potentiometer is just regulating the speed. So I can wind that down a little bit or speed it up a little bit. Yeah, so that's all it's doing. And to find out what's happening at various points, I mean, you know, I've done some work before with relaxation circuits, say LM358, for instance, and I'll link that guy up here. But one of the things which I didn't really do was explore how is it actually working. So it's a classic wave. Let me see if I've got a bit of paper here somewhere. Yeah, so hopefully I can do it justice here. So what you've got is a charging cycle for a capacitor and then a discharge and then a charging cycle and a discharge over time. So that's going to be what happens maybe at this capacitor. And let me see if I can just flare that back in again. It's gone all dark because of the paper. Oh my God, I hate this camera. There we go. Yeah, anyway, I guess it means we can see the LED a little bit better. And yeah, and then at the output, what you're going to get is a square wave. So you're going to get this sort of thing happening. So you get this classic sort of, I mean, really, a lot of times that you see this online, you'll see it connected like that. So that's your square wave output that's produced when the capacitor discharges and charges up again. Now I have a very old and not so good. Well, when I say very old, it's been a couple of years now that I've had this little unit. It is, I'll turn it up the right way, a DSO138, and that is a digital oscilloscope, and a very poor one at that. But anyway, let's get it fired up. What we might do is get a couple of. Let's have a look at the output to start with. So if I maybe take this guy out and put in instead a green lead to indicate the green LED. And then maybe if we've got another one here, let's do this one here. We'll have this coming out as our ground. There we go. And yeah, I think you can see, or hopefully you can see, that there is a square wave that is on the oscilloscope. And that's what I've done before. And you can even see it's blinking here as well as it's picking up that. Let me see if I can turn this around a little bit. Does that help? There's some obnoxious lights here. Let me see if I just get rid of those. If I turn the overheads off, what do we get? Oh, that's a bit nicer. Yeah, that's lovely. Yeah, so that's the famous square wave. Now, if instead, if I put it on the inverting input, and there is the sort of sawtoothy wave which shows what's happening with this capacitor. I think that's a 0.47. I mean, the values actually don't matter because you can change it to what you want. But one thing which, you know, I haven't never been able to do, because this is a single channel oscilloscope, is put those two together. But wait, I now have, courtesy of a school which was giving away or throwing out their old oscilloscopes, the ability to have two channels. So let's put these two together and see what happens. Isn't it magnificent? This is the Chang 6502, related to the Protec, I'm guessing, the Protec being the legit one. I'm not really sure. Probably goes back to the 80s, maybe. Yeah, so I guess the first question is, if we turn it on, are we going to get a signal? I've just got one probe on at the moment, and that is the one for the capacitor. So that is on the inverting output, or input rather, for the TL072. So let's turn this on and see what comes out. Okay, so this has been on the shelf for God knows how many years, but getting a signal at least, that's good. Now I'm going to rely on just fiddling around. So people are going to be screaming at their devices here, but I'll try not to push too many buttons. So hopefully we should be able to see if this thing is working properly. I'm going to start with the time division, and I'm relying on my knowledge of using one of these things from 1981 in a physics class at university. So it could be pretty dodgy. And what I've done with the digital oscilloscope. Well, that's a lovely signal there. Look at that. That is pretty much, yeah, look at that. Probably that one there is nice. So that's pretty much what we want. So we're in DC mode for the first channel and the second channel. We can move, this is the first channel, so we can move it up and down if you wanted to do things like measure voltage. There is a voltage divider on the non-inverting input, so there should be 3 volts coming out. So hopefully it's 3 volts across the board. That's 5 volts, that's 2 volts. Yeah, so that's 1 volt per division, and we're just getting, we move this position here, we're just getting just over 2. Mind you, there is what looks like we could cheat here. In fact, if we go halfway between the extremes for the calibration, I assume it's a calibration. Again, this is something which you could, that's probably about halfway. So I'm guessing it's maybe around 2 volts. I mean, you could cheat and pop it up to 3 if you want. I did measure an output of 3, so maybe it's not too bad to do that. Let me get the position here. Let's call it 3 volts until we know any better. And then in terms of the frequency, we've got, let me just wind this using the potentiometer. So I'll just see if I can wind it out a little bit. There we go. So I'm lowering the frequency, and we're getting divisions. We're getting about 3 divisions per cycle, and we're on 1 millisecond. So you can work out the frequency from there. I'm not, again, there's a calibration button here, and I've not got a signal generator. Well, I do have a signal generator, but I don't know how good it is. But I haven't calibrated it. So I've just put this in the middle here too. You can see that, you know, it would change what that frequency is, but if we just put it in the middle for now, it's not calibrated, but that's okay. This is just proof of concept at this stage. What else can we play with? Well, not too much really. So what we might want to do is bring in the second channel. So let me just hook that up. I'll put a picture up here of the circuit with the probes hooked up. Second channel will be on the output of the actual TL072, the square wave, hopefully. So that is this one here. Okay, nice. So if we just get the voltage, will be, so that's 5, 3, so that's also, and like 1 volt per division. And then if we position that as well, oh, look at that. That's what we're looking for. I see a bit of flickering through the camera, and I guess we can change it. If we increase the frequency, and then if we change the time division, we should be able to cure that and get a rock steady. Yeah, that's not too bad. It's looking pretty good to the eye. So hopefully that's okay as well on the screen. But that is the signal that I was looking for. 2 channels monitored. Should we try a higher frequency? What have I got here? I've got a little tiny, gee, my eyes. I think it's in the picofarad anyway. It's quite a tiny capacitor. So I just pop, I'll do this live, so hopefully I won't blow anything up. But I'll just pop a tiny capacitor in there and see what that means. If I have any dexterity whatsoever, there we go. Oh yeah, you can see that's an increased frequency. So if I change this, oh, okay. So that's it looks like they're following each other. So not so much of a trigger there. We're still getting a wave out of the, let's just turn off the capacitor. So that's the so-called square wave at a much, much higher frequency. We're in the 10 microseconds now and 2 divisions here. We can maybe crank that up a little bit more. Oh, and there it's gone. Yeah. Yeah, that's pretty degraded. If I just go back until it's sort of squarish, so I'm just winding that back. We'll go back a division or 2. Here we go. One more maybe. Yeah, that's sort of squarish. You can still see an interesting little artifact here climbing up. I'm not sure what that's about. A lot to explore here. Let's bring in that second channel. Yeah, that's nice. I'm so impressed by that. It's pretty good. It's going to be pretty nice to have that the 2-channel oscilloscope. As soon as I work out how to drive it, now I will put some work into what all these things do. Apologies if you were screaming away saying, don't do that, don't do that. I'm doing my best. There's a couple other things I could probably play with. There's intensity here, which is obviously pretty self-explanatory. There's a focus here, which is pretty self-explanatory. Scale Ilum. That doesn't seem to do anything. Nope. I'm not sure what that's about. Here's where I guess you could calibrate. It says 0.5 volts. That might be worth actually exploring as well. You can add the 2 traces together, which is interesting. And yeah, obviously do some magnification. Wow. And we can invert the signal. Yeah, nice. So yeah, I'm pretty happy that this is going to form a useful part of the lab bench once I can work out how to use it. Thanks for your company. I'm going to call that the circuit working for this week. We'll see you next time.